Hi everyone. In few moments, um please stay with us. In few minutes, we will be with Tarini Hardikar from qBraid. Thank you and stay tuned, please.
Introduction.
Perfect. Yes.
Okay. So yeah, it's my pleasure to welcome Tarini Hardikar. She has a PhD and is the head of scientific applications product at qBraid, where she leads initiatives that bridge research, education, and product development in quantum computing. Her background spans theoretical chemistry, quantum algorithms, and product strategy for emerging quantum technologies. She has led collaboration with organizations across academia, government, and industry to make quantum computing more accessible and impactful. And she will talk today about qBraid, building the quantum cloud. And the quantum computing is transitioning from a field of isolated experiments to an interconnected ecosystem of hardware, software, and users. At qBraid, they built the infrastructure to make that transition possible, from cloud-based access to quantum devices and simulators to education and training platforms used by thousands of students, researchers, and developers worldwide. This talk will explore how qBraid's ecosystem, including qBraid Lab, qBook, and the qBraid SDK, accelerates learning, experimentation, and collaboration across hardware and frameworks. She'll discuss lessons learned in designing accessible quantum platforms, the challenges of hybrid quantum classical workflows, and how open source and cloud native tools are shaping the next phase of quantum software innovation. With that, I give it to you, Tarini.
Great. Thank you so much for that introduction, Sandra. Hello, everyone. I'm Tarini. Great to meet you today. How are you all doing? Give me a reaction from yeah, you can, react. So, yeah, I see a thumbs up. Okay. Here's my reaction. There we go. How's everyone else doing?
Very good.
Great. All right, so I am going to talk a little bit about what we do at qBraid and how we are building the quantum cloud. I encourage you to ask questions at any point. Please feel free to unmute yourself and ask or put the questions in the chat. I think this will be a lot more useful. You'll get to learn a lot more, and it'll be a lot more fun if it's interactive. So I'll ask questions throughout, and you can put your answers in the chat or you can react. Most of these will be yes, no questions. All right. So with that, let's begin. How many of you have heard of qBraid? Thank you, Sandra. If you have not heard of qBraid, that's completely fine. You can use this no reaction on there. And whether you're on laptop or phone, you have all of these reactions available. Yeah. All right, so we don't seem to have a lot of people who've heard of qBraid, which is all right, because today I will talk about what we do at qBraid. So, uh, can everyone see my screen? Great. So at qBraid, we are building the quantum cloud. And what does that really mean? So at qBraid, we pride ourselves on doing three things. First, we are a quantum computing orchestrator. And what does that mean? That means that we host and provide access to over 20 different quantum computers, CPUs, and GPUs on the cloud. And we have over 24,000 users who have run over 200,000 jobs, quantum calculations using our platform. And so we pride ourselves on kind of bringing all of this together. Next, we are a quantum software integrator. So we have something called qBraid Runtime that bridges over 15 different quantum computing software frameworks across different modalities. Now, this is a Qiskit Fall Fest event, so I'm sure all of you have used Qiskit, but if you've used, say, PennyLane because you're interested in machine learning, or you've used Cirq from Google, or you've used STIM because you're interested in quantum error correction, we bridge all of these different frameworks together. And next, qBraid is a quantum research innovator. So our researchers have been cited over 4,000 times, and we have deep practical experience in converting science into something practical, something that can return business value. So we'd like to think of ourselves as the most connected quantum computing startup in the world. So with our 15 plus different QPUs, over 15 different SDKs, and 24,000 users, we are kind of bringing the quantum industry together. So what does that practically entail, and what tools and products do we have? So first off, there's something called qBook. If you are new to quantum computing, if you're here to learn, qBook is the place to start. This is where we host a whole bunch of different courses, whether it's Cubes, which has over 20,000 students enrolled. It's endorsed by the White House Initiative, really popular um, provide like online learning platform for quantum computing. Or if someone here is a professor or a teaching assistant, qBook can also host your own content. So if you have some courses that you'd like to publish and you'd like the world to see, qBook can help you do that. Next up is qBraid Hacks, which is our hackathon platform. We are one of the most common, if not the most common, hackathon platform provider in the world. So this year, 2025, it's the International Year of Quantum. We've hosted major hackathons everywhere across the world: Thailand, Ghana, Egypt, Greece, Uruguay, the MIT hackathon, Yale hackathon, South Carolina, everywhere across the world we've been hosting hackathons. And this weekend, when you participate in this Qubit Hub hackathon, you can also do that on qBraid. Next up is qBraid Lab, and I'll be giving you a live demo of Lab as well. But qBraid Lab is really great because it's a cloud-based IDE that is custom made and tailor-made for quantum computing. So it's one of the ways you can access all of these different QPUs, monitor and track your quantum jobs, and all of that good stuff. So this is sort of our user level. And then we also have a second layer of products that are more closer to the hardware. And so together we call these three products qBraid OS. And what these do is actually connect the QPU to you. So the qBraid SDK and qBraid runtime are what actually allow you to submit jobs to different quantum computers, access different frameworks, and convert between different frameworks. So for example, your friend gives you code that's written in Circ. You could use the qBraid SDK to convert it to Qiskit. And then you could use qBraid runtime to actually connect to an IBM quantum computer and now submit your Qiskit code to a computer. And then if you have a QPU, if you have hardware, qBraid Gateway is what allows you to connect the software layer to the hardware layer. And together, all of this makes up qBraid OS, our operating system. And so kind of connecting the hardware layer with this user level is qBraid Pilots, where we provide training, upskilling, and research to ensure that you are not just doing quantum computing for the sake of quantum computing, but deriving real value, whether that's research, whether that's education, whether that's business through quantum computing. So what does all of this look like? So beginning with qBraid qBook, as you can see, it's really interactive. You can run code, you can make courses, you can do everything you want right there from this learning platform. And it's highly interactive, as you can see. We'll see a quick demo of this later as well. Next up is our hackathon platform. So here we provide users experience, support, growth, and then exposure to real world problem solving, mentorship, and advice through qBraid hackathons. And again, we can learn more about this later. I know you all have a hackathon this weekend, so be sure to consider using qBraid for that. qBraid Lab is kind of our flagship product here. This is what it looks like. And you can see that it, in many ways, is exactly like Jupyter Hub. But what's really great about this is that we have all of these tools that are on the side here with environments, quantum devices, and quantum jobs. And again, I'll talk more about those later, but that make it extremely convenient and easy for you to learn, for you to build, and for you to deploy your quantum computing applications. And so right there, this user quickly installed a new environment. Now they're checking out what devices are online and available, and they can go back and monitor what quantum jobs have been running and what are not. So really fantastic. qBraid OS, as I was mentioning before, is the end-to-end software stack that brings QPUs to all of these users. So the SDK is kind of the tip of the iceberg there, and it's the world's most comprehensive transpiler. qBraid runtime powers workflows by actually connecting the SDK to the hardware, and the gateway is what connects the hardware API to the qBraid API. Together, all of this forms qBraid OS. So diving a little bit deeper into that, this is what the qBraid SDK really does. And this is why I call it the world's most comprehensive transpiler. Now, whether you are starting out, say, in Qiskit, and now you've decided you want to try some error correction, but you have only Qiskit code, what you can do is convert your Qiskit code to QASM2, so Quantum Assembly Language version 2, that's called QASM2 code with the qBraid SDK, and that in turn can be converted to STIM. If you don't know, STIM is this quantum error correction library by Google. Alternatively, you could also start from Qiskit, convert to Cirq, and then convert to STIM. And as you can see, we have all of these different conversions possible, ensuring that you are not kind of stuck in whatever language, whatever framework you choose. And what's exciting is that this is completely open source, the qBraid SDK. So if you wanted, you were like, hey, I have this program, I think it would be a really good node here, and I can connect it to Cirq, I can connect it to Qiskit. We encourage you to do that. In fact, we welcome you to do that. And our philosophy here is sort of more the merrier. If anyone here is interested in quantum software, please check out the qBraid SDK. It's an incredible repository. As I said, it's open source, and it's a very good place to learn how to work with a lot of different quantum software packages from the get-go. This project actually recently even won National Science Foundation's grant, and we are building a huge open source ecosystem starting from this initiative. So if you're interested, if you want to learn how to contribute to quantum software, this is the place to start. To see this repository, go to github.com/qbraid and you'll get here. All right, so I've roughly been speaking for about a quarter of my time. I'm going to pause here and see if there's any questions. So any questions?
I would have a question. Since you said, it's qBraid is one of the most influential quantum cloud platforms. How did the idea of qBraid emerge, and what inspired its mission to connect research, education, product development under one ecosystem?
Yeah, thank you, Sandra. That's a great question. So qBraid was founded, and its current CEO, that's Kanav Satya. He did his PhD at Dartmouth in chemical physics, and he did a lot of research on quantum chemistry on quantum computers. He also did a couple of internships at IBM and so on, and he saw firsthand how much time people spend, and you could even say how much time ends up getting wasted because of all of these installation and setup issues. And so the idea began to emerge, what if we had something that made quantum computing accessible and made quantum computing convenient? So you could focus on your research and leave all the setup to this platform. And then because of how convenient that made everything, professors really liked it and they started using it for education. And it's grown since then, where we've added more and more functions, services, and so on. But yeah, that's a great question. Thank you, Sandra. Any other questions? All right, time for a question for all of you then. So, how many of you here have participated in Qiskit Global Summer School? No? Okay. That's all right. So every year, IBM runs Qiskit Global Summer School, and it's exactly as it sounds like. It's in the summer. It's completely online, and it's a great school. It's 2 to 3 weeks, I think. And qBraid actually is the host for it. So IBM provides all the material, does the teaching, provides support, and all of it is run on the qBraid platform. So that's one way where we support very wide education and outreach initiatives in the community. And something I think you all should check out. It's a great way to learn. Um, yeah.
You got a question?
Okay. I see a question. How do we handle latency and availability of different quantum systems? Yeah, that's a fantastic question. So the availability of different quantum systems is upon the quantum system provider. So if an IBM device is online, on qBraid, it will be online. If an IBM device is offline, on qBraid, it will be offline. We do not have any control or any power over changing the availability of a hardware system. Because again, we don't provide the hardware, we provide access to the hardware. And then answering the latency part of it, that's a really good question. And that's something where a lot of work is being spent. So if you'd used qBraid 6 months ago versus 12 months ago versus 18 months ago, every 6 months or so, we are putting in a lot of time, effort, and work to ensure that our system has low latency, can handle high workloads, and things don't slow down. For example, now if at summer school or a hackathon, you have 1,000 people all joining in, how do we ensure that everyone gets access to QPUs, everyone gets access to compute they need? And we just keep getting better because of all of this work. And then I see a question, all the frameworks are integrated? Yes, absolutely. You don't need to install anything manually. Yes, that is correct. Yeah, I see a question about where you can take courses. So you can take courses on qbook.qbraid.com to learn about quantum computing. And then if you have questions about qBraid specifically, you can go make an account and qBraid tutorials will show up on the tutorials tab. So kind of going ahead with my presentation, we were talking about the SDK. Now let's talk about runtime. So runtime is what enables all of these workflows. So whether you want NVIDIA and CUDA-Q compatibility, or whether you choose to work locally, so you don't want the cloud interface and you want the VS Code interface, or you want to connect the qBraid API to your API, the runtime makes all of that possible. And this is a very good point because I know a lot of people prefer, oh, I like my VS Code setup. I just want to stick to that. And so that is possible with our VS Code, Windsurf, and Cursor extensions. So you can just search for Quantum Console and you can search for qBraid and you'll find these extensions. So what do we do for community building and quantum accessibility? So for the past handful of years, we've been developing the qBraid PyQIR. QIR stands for Quantum Intermediate Representation. And the goal here is to take the work being done by the QIR folks. You should read more about their website on their website if you're interested. Um, the goal is to allow for language-specific conversions using QIR. And that is sort of universal. So any quantum computer could then hypothetically be able to read it. So whether you're working with Amazon Bracket code, PyTCat, PyQuil, Qiskit, PennyLane, or anything else, through our PyQIR architecture, we sort of interconvert between all of this, convert everything to OpenQASM, which is Open Quantum Assembly, and then qBraid QIR helps convert it down to QIR, which is then sent off to QPUs. And here you can see a quick diagram of that. So this is another open source library and framework that we actively support, and another great place to start participating in quantum software if you're interested. We also host the qBraid algorithms library, which is a Python package for building, simulating, and benchmarking quantum algorithms. We are also part of the QOSF, the Quantum Open Source Foundation. So a lot of members of the qBraid team have been mentors in the past. A lot of our interns actually started out as mentees in the QOSF program, really enjoyed their work, and then ended up doing an internship with us. And so overall, our goal is to make for an easier, more accessible quantum ecosystem, whether that's through upskilling, whether that's through a hackathon, or whether that's through quantum information science and engineering education for all. And we do this with a lot of partners and support from across the world. Part of that is also hackathons. So these are just some locations where we've hosted hackathons in the past. And I think what makes this really exciting is that hackathons are a great entry point. So if you're actually interested, registrations for the 2026 MIT IQ Hack have opened up. This is a great entry point into quantum, and a lot of times prizes are internship interviews or the ability to participate in future hackathons, which makes this super exciting. A large part of qBraid's work is also towards training, so education, outreach, and workforce development. And so we've worked with so many different universities. Just a few examples here: North Carolina A&T, Irvine, Dartmouth, Yale, MIT, Stanford, Cornell, University of Chicago, and we've partnered them with them to teach courses, for internships, to help train their quantum computing student clubs at these universities, um, and developing quantum computing courses at these universities. A really excellent part of this is the qBook platform. So I put the link in the chat. qBook includes the Cube's visual course, which is this first introductory course. This course was endorsed by the White House Q12 initiative. If you fully complete the course, you can officially get certified. And we also help you deploy and build your own courses on here. A really good example of workforce development that we do, and if anyone here is interested about doing this um, for your university or for your classes, please feel free to reach out in the chat or email me afterwards. So what we did here in South Carolina was, first we did an intensive 4-week boot camp for 60 plus students. Actually, I think this year it was close to 100. And after that, at the end of the 4 weeks, we did an in-person hackathon, and qBraid was used as the platform. We provided support. We provided access to qBraid Lab and over 20 different quantum devices. And then the prizes were internships for students, and the winning team went on to the NYU Abu Dhabi hackathon. So this was a hackathon happening in Abu Dhabi. It was super exciting. Um, and so this way, we are building these partnerships and a sense of growth and community, starting with students who are participating and learning, all the way to supporting their uh, like industry and business aspirations. Okay, before I go into research, I see a lot of messages coming in. So let me answer some questions. Um, First question, what do you think will define the next phase? Um, Yeah, that's a really good question. And I think powerful hardware and smarter software will go hand in hand. We see rapid advances in hardware. We are going to see good progress in software. You can't really do one without the other. And I think that's going to be a big hallmark of things going forward. Uh, Many young women in STEM see you as a role model. Thank you. That's great to hear. What challenges have you faced? I think the field is very new and rapidly evolving, so it's a fast-paced field. It's important to keep up with that. And advice I would give is be open to new ideas because it's such a fast-paced field. Things might change. There might be very rapid advancements in hardware, in software. Something that wasn't working could start working with one of these breakthroughs, or conversely, something that worked might no longer be necessary because of one of these breakthroughs. So, generally, in addition to your specialization within the ecosystem, keep an eye out on what's happening broadly in the ecosystem. Always keep learning and be open to ideas and cross collaboration. qBraid has users from all over the world. Have you observed any particular trends, challenges, or opportunities from emerging regions? Not that I'm aware of. I think we have over 24,000 users from over 140 different countries. I have personally never seen any particular like geography-based trends within our users. And then I see the final question is, what is your current strategy for collaborating with universities and research centers globally? Sorry, the chat moved very rapidly. Yeah, that's a great question. Current strategy. If anyone here is working at a university or research center, please do chat with me afterwards. We'd love to support coursework being taught in universities. We'd love to support research being done at universities. And our strategy has been sort of just talking to as many people as we can and taking it from there. I'd love to work with all of you. I handle a lot of our university work, so please feel free to send me an email. I am putting my email in the chat, and I'd love to chat and see if we can use qBraid for your university. Um, Considering the growth of talent in the region, have you explored or do you have plans to establish partnerships with key institutions in Latin America? Yeah, absolutely. We would love to partner with institutions in Latin America, whether that's for research and having a sort of an internship or a research program, whether it's through hackathons like the one happening this weekend, or it's through any educational means with university courses. We'd love to partner. I have my compute and data stored in Azure cloud. Um, what quantum computing resources I have in the cloud to use qBraid to work on optimization problems? Yeah, absolutely. I think if you make a qBraid account, you'll see all of the different QPUs, the compute available to you, and we'll do a quick demo in the time we have left as well. What skills or backgrounds do you look for in students or early career professionals who want to join qBraid? Yeah, that's an excellent question. So qBraid, at the end of the day, we are a pretty small team and we are a pretty young team in that qBraid's only been around for about 5 years as a company. So we are looking for folks who are eager to learn, who are eager to adapt, and who take initiatives, who want to work on problems, or like, oh, that looks interesting, I can solve that, and then they go do it. So, driven, initiative taking folks are who we are looking for. Uh, qBraid Lab is a powerful educational tool. Yes, I absolutely agree. Have you seen it being used as a training platform in university courses or internship programs? Yes, a lot of different universities use qBraid Lab for their courses and for their workforce development. How can institutions integrate it effectively? That's a great question, and we will see that in our demo. All right, going back to our presentation before we head on to the demo, let me talk just very briefly about some of the research that's being done at qBraid. So um, we were part of the Quantum for Bio project up through the end of phase 2. So we were there for 18 months, and we worked on this algorithm, this pipeline called the QuantaBind pipeline, where we developed algorithms to tackle problems in human health. So we were studying proteins. So starting with the protein, we would fragment the protein using something called fragment molecular orbital method. And then we would use these different methods, quantum bootstrap embedding and localized active space VQE, to study the classically intractable problem. The classically tractable part would be handled by HPC. We used GSE, Generalized Superfast Encoding, which was actually developed by the CEO and co-founder of qBraid during his PhD. And then that is used to map the chemistry problem to a qubit problem and then sent to a quantum computer. In addition to that, we've also done a lot of research in aerospace applications. We work extensively with Airbus. We've also filed a patent with them to use different types of quantum machine learning to study problems broadly applicable to the aerospace engineering industry. And we do these research projects as part of workforce development. So we work with universities where we have workforce development contracts, and we help students with their master's and PhD theses in quantum computing, whether that's by providing mentorship, providing compute, or in any other advisory capacities. So with that, please get in touch with us. Let me stop sharing for a second here. And before we go on to more questions, let me actually show you what qBraid looks like. All right, so if you haven't made an account with qBraid yet, I strongly encourage you to go ahead and do that. And once you make an account and log in, you will come to your homepage, which will look something like this. What's really interesting is just 1 week ago on November 2nd, we hosted Quantum Developer Day, where we released a second brand new version of our platform. I'm not showing you that today because for this hackathon and for the next couple of weeks, we will still be on this version. But stay tuned because a new version is coming with a lot more features. Not to say that this version isn't feature rich already. So as you can see, we have a hackathons tab. Here you can see a lot of different hackathons that were hosted on our platform. This is by no means an exhaustive list. Uh, if you are new and you like learning visually, you can also come here and play around with Quantum Composer, where this was written by Craig Gidney, so not written by qBraid, but it's open source and we provide support for it, where you can drag and drop gates and learn about quantum computing. So I could have an X gate, I could make this a C naught gate, uh, and then I could add in a Z gate, and then let's see, stuff like that. So you can run things and you can learn visually. Then we have the courses tab here. So actually, let me show you by going here. So you go to qbook.qbraid.com and you can learn all about all of these different courses. So I would recommend starting here if you're new at the Qubes beginner course. As you can see, over 21,000 users have taken it. And this course is incredibly interactive, as is the qBook platform generally. So if you're teaching right now, or if you're interested in teaching and you have material that you'd like to publish, please reach out. We'd love to host material. So there's all these interactive widgets. You can run any code. So you could be submitting a calculation to a quantum computer right from here. So this ran right now. This is not like predefined in any way. It's live and interactive. So hello qubit hub. And then we can run this. And now we can run a simulation. We see that we got 0, 507 times from this circuit that we ran the first time. So we ran this circuit. We got 0, 507 times. We got 1, 517 times. We can plot it. We can see the results. And so qBook is incredibly interactive. It also supports like quizzes, homework, stuff like that. So there's all these quizzes, you could submit your answers. You could also have not just MCQs, not just multiple choice questions, but also like typing questions that test your understanding and so on. And so this is the courses tab that takes you to qBook. And then what's the most important thing you can do from here is launch an instance of lab. And so here I have one instance launched already. And so this is the really cool part, the different environments. So here you can see, and someone was asking, I hope this answers your question. All of these frameworks are already built for you. All you have to do is click on what you need. So if you are working in Qiskit, come here, click on Qiskit. You will see all of these different versions of Qiskit. Now, if you want the latest version, you'll come here, click on install, and it's going to go ahead and install for you. And it's not just Qiskit, right? It's Cirq, Amazon Braket, Pikewill and Rigetti, some hybrid combination. All of these different environments are pre-built for you. You could also think of it with subject matter. So if you're interested in quantum chemistry, we have an environment pre-built for you. If you're interested in, say, benchmarking, there's a couple of different environments for you, and so on. Of course, if none of these work, you could also go ahead and make your custom environment. So you could say my test environment. You could make your own environment. I don't want to do that right now, but just to show you. And what's really cool is you can also share environments. So for example, this was a workshop I did. So I made this environment. I shared it with people. At IEEE Quantum Week 25, I taught a tutorial. So we made this environment and shared it with people. And so it's really easy to exactly tell people what version of what package you're using. The people just come here and click install. You don't have to worry about any other details. Then another really cool feature is right here with devices. You can see what devices are available. So right now we have about 21 devices available. Some of them are online, such as IonQ Forte 1 is online. And the pricing is written right here. So it's 30 credits. So that's 30 cents in US dollars per task, and then 8 credits per shot. But for example, IonQ's Aria 1 is offline right now. It's down for maintenance, I'm guessing. Another example is IQM Garnet. Um, it's not just available, there are no pending jobs. So if we submitted a calculation to IQM right now, it would go right through. And the pricing for this is much cheaper. It's 30 credits per task, but only 0.14 credits per shot, and so on. So you can see all of these different devices that are available. Once you submit a job to a device and you get the results back, you can come here to the jobs page and you can analyze like what happened. So the last job I ran was about a month ago. It was on IQM Garnet. It was 175 credits, so that's 175 cents. I ran a single qubit job, so this was probably some benchmarking work I was doing. And I can see the results right here. I got 1 978 times and I got 0 22 times. And so this way you can see your results for any jobs you've run in the past. So I ran a lot of AWS jobs, for example, and so on and so forth. In addition to these 3 tabs here, which are some of the most useful quantum features, there's also like Git compatibility. You can see like a lot of different code snippets and so on. What's really interesting is right now I'm running just a RAM instance, but you could run any level of compute that you wanted. So instead of a 4 GB RAM instance, you could run a VS Code beta instance, you could run a 25 GB RAM, Or you could also access GPUs from qBraid. So you could be running 8 Blackwells. So these are Blackwells 200. Right from here, you would say, click here, click on Launch Lab. We'd have 8 Blackwells up and running in a few minutes. H100s with different capacity, Grace Hoppers, A100s, so on and so forth. So we have a lot of different options for CPU, GPU, and QPU on qBraid. Any questions? Okay, how are we encouraging interdisciplinary training? Yeah, great question. So, with all of our education and outreach work, we teach people that it's not just enough to think about the quantum computing, but it's important to think about the math, the physics, and the applications. And one of the biggest things going forward is going to be people who can understand these different topics and kind of be the connectors, the liaisons between the physicists and the mathematicians and the computer scientists and so on. That being said, I would not let not knowing one field stop you from participating. If you're here with a background in CS, you don't need to understand everything about quantum mechanics to do quantum computing. If you're here as a physicist, you don't need to be an expert in software or be like a software developer to participate in quantum computing. What you know is a good starting point. So don't worry like, oh, I have to go learn this like whole thing. Start participating, start thinking about what you're interested in, and go from there. Can we build and run the qBraid lab and run time in private or on-prem environment for security and compliance? Yeah, so we can do that for you. That is a paid service. You can't just like take qBraid lab and run it on-prem yourself. Do you see customers running qBraid in their own environment? I'm guessing you mean like on-prem environments, Yig. And yes, we do have customers who want that or like on their own on-prem cloud. Yeah, absolutely. They do that. If you just mean like an environment on Environment Manager, anyone can create an environment. If you mean like on-prem cloud or custom deployment like that, yes, that's possible. That is paid. What role does classical AI play in optimizing quantum workflows? Yeah, that's a great question. And right now, a lot of AI is being used to improve quantum computing. So people are using AI for quantum optimization, for circuit optimization, for error correction, denoising, for building decoders. So, excuse me. It's a very big active area of research. In fact, qBraid hosted an AI for quantum conference in San Francisco a few months ago. So I encourage you to check out papers in this field. It's a very active area of research. Um, as head of scientific applications and product, you sit at the intersection of science and business. What are the biggest challenges you face when translating complex quantum research into scalable cloud products? Yeah, that's a very good question. So, um, one of the biggest challenges is kind of timing, right? So quantum hardware is still relatively new right now. And of course, there's no point in waiting until hardware is perfect because that's not how research works, right? You do research as the hardware evolves, so the research evolves, and so on and so forth. And so it's important to figure out what problem can be solved when. And so our work isn't targeting hard like a quantum computer 10 years from now, or we are not just talking about potential, but figuring out what's possible now and who's going to benefit from it. And then I see a question about Pascal. Does qBraid transpiler support converting circuits into the pulsar format? Yes, absolutely. We do support that. Um, Monetization model for businesses versus academics. Yeah, great question. So if you join qBraid using a .edu ID, you will get roughly 50% off on a lot of our features. If you are buying something for your university, say you are a professor or you're a quantum computing club, before you buy anything, feel free to send us an email, talk to us about what you need, and um, we'll figure out how to get some more discounts for you. What's your advice for those trying to transition from classical software to quantum computing? Yeah, that's a good question. Um, Very practically, I encourage you to check out the Quantum Software Engineering course on qBook. It's a great course with exactly you as the target audience. It's meant for people who know programming, who have a background in software, but classical software, and who are interested in the quantum software. So check out that course. But broadly, I'd say don't worry too much about quantum mechanics. You don't think about classical software, right? Sometimes you have to understand everything you're doing, but a lot of times you have to understand software, not the research topic at hand. So if you are in classical software, think about what you want to achieve with quantum software and then learn that. If that involves learning physics, great, go for it. If that involves learning optimization, go for it. If you want to do applications to chemistry, go learn chemistry. But don't stop yourself just because you're like, oh, I don't know any of this. That's okay. You will learn, but pick one lane and then learn that. What do you think will be the biggest training challenge as quantum technologies move from research to commercialization? Yeah, I think that's a very good question and something a lot of people are thinking a lot about. It's estimated that in the next like 10 to 15 years, there's going to be a 3x gap between roles and trained people to fulfill those roles. What I mean by that is suppose there are 90 openings, there will only be 30 trained people. So that's what a survey from McKinsey said. I'm not making that up. And so one of the biggest challenges is how to scale, whether that's scaling training, whether that's scaling technologies, and how do we efficiently think beyond research to business, to commercialization. Even if you think about like classical, say, manufacturing, right? Uh, if you think about like any ibuprofen or any other medicine, it was first invented in some lab somewhere where some grad student was probably making it on like a milligram or a nanogram scale. And then they made it successfully. They published, they got a patent, and then people figured out how to make that nanogram 10-step reaction into something that's commercially possible so that it can be made at a big scale and it can be made into medicine and be bought at a big scale. So it's the same entire process, but now with quantum software and quantum hardware.
So you have in qBraid the training for, from computer science to come to quantum computing. Do you have also for, let's say, quantum physicists, how to understand the computing part and maybe the software if they want to, get more into that area?
Yeah, that's a good question. Right now, I would encourage you to check out the qINTS course, but we don't have a custom course for that target audience, but we will in the coming 6 months or so. Yeah.
That's good. Next question.
Where do you see cloud architects? Yeah, we have a big need for you. So cloud architects and deploying to the cloud scaling are all really important features. When we add more features, when we put more compute on the cloud, how is it safe? How is it secure? How is it scalable? Um, how is the workload balance? Are all really important questions. And I think there's a big need for cloud architects in the field right now. Yes, exactly. And a very big active area of research, including like work IBM is doing, work IQM is doing, is this like heterogeneous hardware, right? So you start with something, you run it on CPU. The CPU identifies what's difficult and how is it difficult. So then you send part of the problem to a QPU, you send part of the problem to the GPU, and the CPU is sitting there kind of being like, oh, let me coordinate all the output I'm getting. And so this heterogeneous hardware architecture, managing workloads, managing parallelization, and just managing communication is a very big active area of research right now.
How does qBraid see, for example, yeah, coming also with open science, how much did it influence qBraid? How much is this with, open source products maybe available that you have a community that can help further develop also parts of the software?
Yeah, absolutely. I think the quantum software industry right now is doing very well on the open source front. So whether it's Qiskit, Cirq, STIM, Metique, all of these are open source. We have the Unitary Foundation, which if folks here you haven't heard of them, please check them out. They do incredible work, Unitary Foundation. They host a lot of different software packages that are all open source. They do like weekly community calls. And then at qBraid, we also believe a lot in having a robust like community. And so the qBraid SDK is open source, quantum intermediate representation at qBraid is open source, PyChasm, which is this Python tooling for the quantum assembly language that we host, is also open source. We are also a dependency in a lot of other open source packages. So we strongly believe in supporting this community. With actually the new NSF grant we won recently, we are really working on not just having open source software, but actually building a healthy ecosystem where people are benefiting from it, contributing to it, and actively using it as well.
I don't have the schedule at the moment, but yeah, Unitary Foundation will also give a talk, I think, in the next 2 days or 3 days. So if
Wonderful.
yeah,
Yeah, yeah.
that's so okay. I think we still have time for 2 questions.
If you could send one message to every young person considering a quantum career. Um, I will give two answers, so I'm sorry, it's not one message. Um, my first answer is in a very optimistic world where quantum computing really takes off, both scientifically and commercially. So, what I mean by that is there are research successes in the quantum industry and there's money in the quantum ecosystem. In that case, my message to every young person would be this is the time of your lives. Learn as much as you can, build as much as you can, be open, be flexible, uh, and be excited because uh, it's kind of like becoming a ML scientist in like 2005, right? You'll be one of those people who has 15 years of experience when ChatGPT is released, something like that. You'll be one of the early adopters. My second message is a little bit more cautious because at the end of the day, quantum computing is still a very young technology, not scientifically, but commercially. And so ensure that you're learning skills that are translatable, that are so if you're in quantum software, figure out how to ensure that your software skills are as sharp as your quantum skills. If you're in hardware, figure out what all those control things could be used in classical world. If you're in photonics, great. I think that's very applicable. So ensure that you have translatable skills in case things don't go your way.
That is great. So how for the next 5 years, let's say, you envision qBraid's trajectory, what will happen? What do you think? With
Yeah, I think at qBraid we are optimistic, but without the hype. As a company, as individuals, we all really believe that the hype doesn't help anyone. It only hurts us. And so, being scientifically grounded, being mindful, we think it's a good time to be cautiously optimistic. There's really great advances in hardware. We have more and more logical qubits than ever before. There's great advances in error correction, in quantum software, in application. And so at qBraid, we are really excited about the next 5 years and for our role as kind of an integrator in bringing software, hardware, applications all together.
Great.
Once again, I want to put my email in the chat if you are interested in exploring qBraid for your university, for your course. Please reach out, and I'd love to chat some more.
This is fantastic. Thank you for a fantastic talk and very engaging. And with this, if there are no further questions, I give it then to qubit Hub.
Well, thank you so much. And please reach out if you have any questions.
Thank you, Tarini, for this excellent talk and for showing us the capabilities of qBook Lab and answering all your questions. I hope we can have another talk to you in the future and that you can show us the new advance of qBraid.
Wonderful. Absolutely. I'm looking forward to that as well.
Thank you.
All right. Thank you. Have a good day.
You too.
You too, say. And thank you all for joining us today in this fifth day of Kiski Fall Fest 2025 by Qubit Hub. We hope you enjoyed today's talks. We look forward to seeing you tomorrow on the sixth day on this great event, which starts at the 7 a.m. Chicago time. And see you tomorrow.
Have a good evening, night, wherever you are.